All right, so I think I'm live now. Can someone confirm if I'm live? All right. Okay, I think we can start now. I don't see many people joining the stream today. Why is that? And I don't see anybody responding. Am I audible? Rishabh says yes. Okay, perfect. Okay, let's start now. Okay, yes. Okay, I think there is some lag. Okay, so let's start. I'll be doing problem A, B, C, D, E, and F1. Okay, I didn't really get time to see F2 or like try to solve F2. Yes, sir, because you put stream time at 10 p.m. I was not able to solve D and F1, so people don't know that stream is starting at 11. Okay, yes, sir. Okay, cool. All right, so I think we can start now. I'll go in order only. I'll start from problem A and then move forward till F1. Before that, I would like to know like how many problems were you all able to solve? For me, I was able to solve A, B, C, D, and F1. I wasted like around 1.5 hours in D because my solution was correct, but I instead of using a multiset, I was using a set, and that's why I was getting a wrong answer on test 3. So I wasted all my time in D, and like if like after I submitted D at like 2 hour 15 minutes, and then instantly I read F1 and then submitted it. But yeah, if I had time, I'm pretty sure like I would have done E as well. Avinav says A, B, and C only. Okay, that's good. Fumblehead says A, B. Rishabh says 4. Really nice, Rishabh. Okay. Okay, cool. Okay, let's start now. I'll start with problem A, which I suppose almost everyone was able to do. We have around 7.5 thousand submissions here. So, pretty easy problem. Okay, let me just read out the problem. There are n logs. The ith log has a length of AI meters. Since chopping logs is tiring work, Aragon and Mono have decided to play a game. Aragon and Mono will take turns chopping the logs with Aragon chopping first. On his turn, the player will pick up a log and chop it into two pieces. If the length of the chosen log is x, then the length of the resulting pieces are y and z. Then y and z have the positive integers where x is equals to y plus z. Okay, so basically, you have a log, let's say, and its length is x. You divide this into two parts, y and z. Okay, y and z both have to be positive, and y plus z should be equal to x. Okay, now the player who is unable to make a chop will be loser, assuming that both Aragon and Mono will play optimally. Who will be the winner? So let's say Aragon is denoted using E and Mono is denoted using M. Okay, and Aragon goes first. Okay, let's try to okay, let's look at the test cases first. Okay, so if you see in the second test case, actually we only have one log with a length of 1. That means in the very first turn only Aragon is not able to cut it, therefore Aragon loses, therefore M Mono wins, and that is the answer. Okay, now what if instead of 1 we had a 4? What all ways do we have to break this? One way would have been 2 plus 2, and then this is 1 and 1, and then this is 1 and 1. So one iteration for this, one iteration for this, one iteration for this. So one chance by this, one chance by M, one more chance by Ano, and then Mono won't be able to play, therefore Aragon wins. But if you look at this test case, okay, or let's look at other ways also. Instead of cutting it as 2 plus 2, what if we did 1 plus 3? Then this 3 can be further cut into 1 and 2, and this 2 can be further cut into 1 and 1. So 1 operation, 2 operation, 3 operation. So again 3 operation. That means no matter how you cut it, there will be n minus 1 operations. So if you had a log with a size x, then to cut this into 1 1 pieces of length 1, we will have x minus 1 operations. So if we have A1, A2, A3 till AN, the total number of operations required for A1 would be A1 minus 1. For A2, it will be A2 minus 1. For A3, it will be A3 minus 1, and so on, which is actually nothing but sum of all the values minus n. Now, these are the total number of operations that are possible. If this percentage 2, okay, if this is equal to 0, that means even number of chances were done. That means first Aragon played, then Mono played, then Aragon played, and then Mono played, and so on. And in the end, Aragon was not able to move, therefore Mono wins. So if sum minus n percentage 2 is equal to 0, then Mono wins, otherwise Aragon wins. Okay, let me show you the code as well. All right. Why is it not showing me my code here? Just a second. Yeah, okay. All right, so this is my code. Okay, so I just found out the sum of the complete array, then subtracted n. Then if it's divisible by 2, then mono is the answer, otherwise Aragon is the answer. And that's it. Okay, I think we can move on to problem B now. Okay, so let me just do that. Okay, okay, just give me a second. Okay. Hi, I guess it would be better if you reduce screen allocation of face cam and increase for whiteboard. I have been thinking about this. I'm actually thinking from next stream, I can actually put myself on the right side and then have a good view for the board and the, what do we say, Codeforces. Alright, anyways, let's move on to problem B now. Okay, so problem B. Let's call a string good. Okay, I hope A is clear to everyone now. Let's call a string good if its length is at least 2 and all its characters are A except for the last character, which is B. The good strings are A, B, A, B. So, okay. So, good strings can be A, B, A, B, triple A, B, and so on. So, basically, first you have a set of A's and then you have a single B. And this is a good string. Okay. Now, you're given initially empty string S1. You can perform the following operation any number of times. Choose any position of S1 and insert some good string in that position. So if this is the complete, initially you have an empty string. Let's say we inserted AAB. Now we thought, how about we insert AB in between here as well. So it becomes triple A, BB, and so on. So we keep on going. Okay. Now, given a string S2, can we turn S1 to S2 after some probable operations? So let's take some inputs. Okay. So we have what? AAB, AB. This is easily possible using first we have AAB, then we added AB in the end, and hence we got it. The next case is A, B, and B. Now, first we added AB, but then if you see, there is no way we can add only B. Therefore, the answer for this is no. Okay, let's take another test case. Let's take which one? The third test case has many A's first, so on, and then B. So this is also possible. Now, if you see, there are a few things which are very clear. Okay, the first letter has to be A. First letter. Okay, B has to be last letter. Okay, then the number of A's should always be greater than B in the prefix, because let's say we added A, B. Then let's say we thought of adding another AB here. So we had A, B, and B. Now we thought of adding like 3 A's, then AB here. So A, B, B, and B, and so on. If you see, whenever you are adding a B, more number of A are being added. So at any point, count of A's should be greater than count of B's. And that's it. That is all you have to implement. Okay, and that's it. I'll quickly show my code as well. So this is the code. So initially what I'm actually doing is I'm just checking if length of s is 1, then also no. If the last letter is not B, then no. If the first letter is not A, then no. Otherwise, I just see, okay, I made a count variable which is equals to 1. Okay, and I'm starting from 1 till the length of the string. The reason is because I know i's 0th index is already equals to A. So my count is also equals to 1. If my SI is equals to B, then I make count minus minus. Otherwise, I just increase my count because it's an A. And at every point, I just see if my count is greater than 0. If it is less than 0, that means this is not possible. And I just break out of the loop with a flag 1. And then I print no. And that's it. All right. So hopefully, this is also clear to everyone now. And I think we can move on to problem C. Okay. As C की language ने confuse कर दिया, could not implement C. Okay. D नहीं हुआ, D का logic क्या था? Okay, cool. Okay, I think B is clear and we can move forward to problem C. Problem C is unequal array. I don't really remember any of these questions now. Let me just myself read. Okay. Now, you're given an array A of length n. We define the equality of the array as the number of indices such that AI is equals to AI plus 1. We are allowed to do the following operations. Select two integers I and x such that I is from 1 till n minus 1 and x is something. Then set AI and AI plus 1 to be equal to x. Okay. So, what they're essentially saying is that, let's say we have 1, 2, 2, 3 and 3. Now, they are saying that since 2 and 2 are same, okay, is that what they're saying? Okay, no. We can actually select any two indexes, any one index actually. Let's say we selected this index. Now we can actually insert a new value for this index and the next index. So let's say we inserted 4. So it becomes 1, 2, 4, 4 and 3. Equality of this array was 2 because this 2 and this 2 was same, this 3 and this 3 was same. So basically there were two pair of indexes where the values were same. Consecutive indexes. Okay. Similarly, but the equality of this now becomes 1. Okay. Now find the minimum number of operations needed such that the equality of the array is less than or equals to 1. Now, why are we given that the equality of the array is less than or equal to 1? The reason is because every time we are adding a new value, it is to be added at index I and I plus 1. So after every operation, we'll at least have equality of 1. Okay. Alright, so how do we do this? Now let's take a couple of test cases first. Let's say we took the very first test case and it is 5 times 1. So we have 1, 1, 1, 1 and 1. One way of doing this would be, first we made an operation at this position. So it becomes 1, 2, 2, 1, 1. Okay. Then we made an operation at this position. So it becomes 1, 2, 3, 3, 1. Equality of this was 4 because this is equal to this is equal to this is equal to this. So equality becomes 4. In this, the equality is 2 because this index is equal to this one, this is equal to this one. So equality of this is 2. But equality of this is 1 because we have 3 and 3 here only. Which means in two operations, we were able to drop the equality from 4 to 1 and this is the least equality we can get. So the answer for this is 2. Let's take another test case. Let's take the third test case. Okay. So we have 1, 1, 2, 3, 3, 4. Now this and this index is same. So we need one operation here. Okay. But if we did one operation here, okay, let's do that only. We have 1, let's say we inserted 5 because 5 is not present. So we have 1, 5, 5, 3, 3, 4. Now if you see, you have equality initially was 2. Again equality is 2. That means this operation was not useful. So instead of doing this, what we can do is we can actually take this 3 and change. We have what? 1, 1, 2 and 3 and then this 3 becomes what? 5 and next is also 5. Okay, how do we change that actually? I didn't really think about this. So in order to drop the equality from this to this, we need to do one operation. Okay, so basically the idea is not like this. Okay, so we have to do, we have 1 1. Okay, we had 1 4 5, sorry. So we first took this index and we made this 1 5 5 3 3 4. Then we took this index and we made this 1 5 6 6 3 and 4. And now the equality of this is 1 only. Now how to do this? Let's first consider how much operations do we need if we have ones or any same number in a row. So we already saw that when we have like 5 ones, if we have 5 ones, the answer for this is 2. Okay, now what if we had 6 ones? If we had 6 ones, the answer of this would have been 3. Now if you see in the problem statement, we are actually given that, let's say this is the complete array. And let's say first we had 1 only, then we had a couple of 2s, then we had a couple of 3s, then we had, let's say, one single 4 only, then we had some 5s, then we had a single 6, and then 7 8. Let's say this is the array. We know that in order to make these 3 2s okay, we need to make how many operations? What? One operation to make this, like, let's say let's make this 0 0 0 0. Even after that, one equality will be left in this. Even after, no matter how many operations we do in this, some equality will be left in this. Okay, similarly for this also, and similarly for this also. So there is no it is not beneficial for us to process them in groups. Instead, we can actually consider this complete string as one group only, and we can just make all the operations in order. So first we make operations on these two values, then we make operation in these two values, then on these two, then on these two, and so on. And we already know that for a length of n, we have to make n minus 3 operations, because for 5 the answer was 2, for 6 the answer was 3. So through this we get that for a length of n, we have to make n minus 3 operations. So we have to do the same thing only, we just have to find out the length of this string, which has all the consecutive values, and then the answer will be, let's say the length of this is n, the answer will be n minus 3. And that's it. Okay. Now, again, there are a couple of edge cases in this one. What if there are no consecutive values? If there are no consecutive values, then the answer is 0. Okay, or what if n is equals to 3? What if n is equals to 3? What if you have 1, 1 and 1 only? Then you need to make at least one operation to make this 1, 2 and 2. So that is also one more thing that you have to make sure. So all you can do to do that is max of 1 comma n minus 3. Okay, now let me just show the code also. Again, a pretty simple problem, a few edge cases. Okay, I don't see many people liking the stream. I only have 18 likes to the stream. Do like it, guys, and let me show the code of problem scene. Okay, so what I'm essentially doing is I scanned the complete array. Okay, then I started from the very beginning and saw which index has two consecutive values as same. I marked that as the starting index and then broke out of the loop. Then I did the same thing for the reverse array to find out the ending part of that string, where I have two consecutive values equal. And then I just said that my answer is max of 1 comma end minus start minus 2. This is actually end minus start plus 1 minus 3, because the length of my segment is end minus start plus 1. And then I had to subtract minus 3, so I just made it end minus start minus 2. And that's it. This condition is that if if the length is 2 only, like if my end is actually equals to start plus 1, that means my n was equals to 2. And if my n is equals to 2, that means my equality is 1, because I only have two consecutive ones. That means my equality is 1, and I don't have to make any operations. Okay. Or if my start is not equal to minus 1, which means that I at least need one pair of consecutive values. And that's it. Okay, so this was problem C. I think we can move on to problem D now. If anyone wants my code or wants to have a better look at the code, they can just go to my Codeforces submissions and then like see the code. Okay. Moving on to problem D now, which is a good problem. Okay. At least for me, I wasted like way too much time. Why we did not process the group separately? We did not process the group separately because whenever we are processing a group, every group will give us a equality of 1, because we need to change the values in pairs. We need to take two consecutive values and we need to make them some new value, which is x. Okay, so in the end every group will have an equality of 1, so it's better to club all the groups and then find how many operations we have to do. Okay, all right, let's move on to problem D now. Okay, all right, for me problem D, I wasted almost all my time on problem D. How do you implement D? I'll show you how you implement D. I actually wasted way too much time in D. If I show you, let me even analyze like how I did. If I show you, okay. If you see, uh, I actually submitted C at 38th minute. Then I submitted my first solution of D at 1 hour 3 minutes. And then till 2 hour 44 minutes, I kept on going for D. Whereas my solution was perfectly right. I just had to replace my set with a multi-set. And that's it. So essentially, I wasted like uh, one like one more than 1.5 hour just on problem D without any reason. And then I just like submitted F1 in 13 minutes. In today's contest, many CM and masters also choked on D. Even tourist himself. What was the reason? Yeah, I was also seeing that tourist actually got a wrong answer on D, and then he couldn't submit D for a long time. I don't know. Maybe, matlab, it was a tricky problem. For sure. Like I myself wasted like more than 2 hours on problem D. So yeah, it was a tricky problem, I would say. But yeah, the solution is pretty simple, and like if you understand the solution, then you'll be like, okay, this was pretty straightforward. Okay, so there is an array A of length n. You may perform the following operation any number of times. Choose two indexes L and R where L is less than R less than n, and AL is equals to AR. Then set A. Okay, so essentially what you need to do is, let me take a test case also. Let's okay, let me take a better test case. So we have 1, 2, 4, 2, and 1. We know that this 2 and this 2 are equal. So we need to take this array and rotate this. This becomes 1, 4, 2, and 2. So essentially, if we took, let's say, A1, A2, A3, A4, A5, and assume that A1 and A5 had the same value, then this array would become A2, A3, A4, A5, A1. In one operation, we can actually make this array this. So we are technically left cycling this array. That's it. Okay. Now you're given an array. Okay, you're given an array A. You can do as many operations as you want, and you're given an array B. Okay, you need to figure out if there is a way to convert array A into array B. Okay, if there is a way, then you just have to print yes. Otherwise, you have to print no. That's it. Now, how do we do this problem? Let me take a couple of test cases. Okay, so let me take the very first test case only first. We have 1, 2, 3, 3, 2. Okay. All we have to do is we have this to same, this to same. So we can actually change this into 1, 3, 3, 2, and 2. And this is the required B array. Similarly, for the next case, we had what? 1, 2, 4, 2, 1. Okay. First, we shuffled this 2 and 2. So we had 1, 4, 2, and 2, and 1. Then we shuffled this 1 and 1. So we got 4, 2, 2, 1, and 1. Okay. So again, the answer for this is yes, because the B array is 4, 2, 2, 1, 1. Now, how do we solve this? Okay. Now, let me, okay. Okay, let me jump onto my board only to explain this. Okay. Let me take a pretty big test case. Okay. So, let's say we had 3, 4, 5, 5, 4, 1, 2, 4, 1, 1, 2, let's say. And this was my B. Okay. 3, 4, 5, 5. 3, 4, 5, 5, 1, 1, 2. and let me take my, this is B, and my A is, let's say, 1, 5, 3, 4, 5, 1 and 2. 1 and 2. Let's say this was my A. What you need to do is, if you see, okay, let's say this was my complete array, and let's say this is X. I know that if I have an X beforehand also, what I can do is I can actually take this X, bring it here, okay, so that this X comes here, and shift this complete array one step this one. So essentially my array would become this part here, then X and X. Okay. So what you need to do is, let's say we are starting in this array and we are at this 3. Okay. We are at this 3. First we try to see where is the very first 3 we have in this array. We say that we have this 3 here. And let's mark 1 and 5 as something we can use later. Okay. Let's mark that we have to use 1 and 3 somewhere later in the game. Okay. And we took this 3. Okay, or let me just make a circle at 3. So we said that this 3 and this 3 are same, let's say. Now my next value is 4, and I say that my next value is also 4, so we can assume that this 4 is also taken through this only. Again, my next value is 5, so we say this 5 and this 5 are same. But if you see, I need another 5 in the next position, but I don't have any 5. So what I do is, I try to see if my last value which I process, which is this X, if my last value which I use is equals to the value that I need. Since this 5 and this 5 are same, I would ask myself, is there any 5 which I did not process beforehand? Since I had another 5 which I did not process beforehand, I'll actually take this 5 and bring it here. Okay, so my array would become 3, 4, 5 and 5. And now I can actually use this 5 for this one. Okay, so I just took this complete array and cyclically shifted it. Okay, and now my this 5 is also used. Now I need a 1. Now I'm at 1 only, and the next value that I need is 1. So again, I'll say that this is present. But for the next value, I say that I need a 2. Sorry, I have a 2, but I need a 1. Now I'll say, is my last value which I use a 1? Yes, it is a 1. That means I need to see if there is another 1 which is present in the array which I did not use. Since this one is present, we can actually take this complete array, cyclically shift it so that it becomes here. And now this one is also used. And now we are left with this 2 only, and this 2 is same. So the answer of this becomes yes. And that is all you had to do. Okay. So yeah, maybe some of you are confused. I'll explain this part again. So what is happening essentially is that, let's say we had a big array and we had a X. Now this X will ask me, is there any X beforehand which I did not use? Let's say I had another X here. So this will say that, let me take this array and cycle this. This X will come right before this X. This X will shift right here. So this complete array will be shifted by 1. This X will come here, and the new array would become the complete array and then X and X. And that's it. That is the whole logic of this problem. Okay. Should I explain this again, this part again? Or is that okay? How do we know that the order is same? We are actually maintaining the order. The values which are getting as same, we are just continuing. But whenever we are not getting a value, we see if a value beforehand is present. If it is present, then we can just shift it. We can just ask that value to come in the end and shift the rest of the array beforehand. And that is all you have to do. Okay. I'm pretty sure like for D, people wrote many complex ways, but I think like my code is somewhat easier. Okay, because I was looking at people's submissions. Okay, again please. Okay, let me explain this part again. Okay, so what we have is, my B array is 3, 4, 5, 5, 1, 1 and 2. Okay, and my A array is 1, 5, 3, 4, 5, 1, and now. Okay, cool. How do we do this? The first value is 3. So we ask in A when do we get the very first 3? So we have the very first 3. So our index at the moment is here and 3 is used. Now we increment our index from 3 to 4 in the B array. Now we say, is the next value after 3 a 4? Yes, it's a 4. So we take this 4 as well. Again increment, we get onto this 5, we get onto this 5. Again these values are same. So we say that this 5 is also used now. Now the next value which B wants in the array is 5. But the next value which A has is 1. So this 5 will say that let me assume that I am an X. And I know that I have an X in the array somewhere before. Okay, so what I can do is I can actually take this complete array and cycle this. Or let's say we had 5 here and 1 here. This is a better example. Okay. So let's say we had a X here, and this will say that what if we cycle around? All these values will be shifted by left in by 1, and then we'll have 2 X's. So if we had like A, B, C here, it would become A, B, C, and then X and X. So essentially this complete array would now become 1, 3, 4, 5 and 5, out of which this 3, 4 and 5 were used, and now this 5 will be used for this 5. And then we'll again increment, we'll increment this to this. Okay, now we'll see that this one is equal to this one, so we'll take this one. Okay, this 5 is used. Then again we'll come on to 1. Now we'll say that we need a 1 but A has a 2. So we will ask, is the last value used a 1? If it is a 1, that means we can apply this logic again, because we know we already have an A present which is not used. So we can take this complete array and shift this. So now the new array would become 3, 4, 5, 5, 1 and 1. And this one will be the array which we the value we had in the very starting, and we will use this one for this one. And then we have 2 and 2. So yes, the answer of this becomes yes. And that's it. Okay. If value is more than 2 times, a good problem. Okay. What if we had a value more than 2 times? Let's say we had an X here, we had an X here, we had an X here. Okay. All right. This X will say, which X should I take? Should I take this one or should I take this one? Okay. Or for the better, let's say, how do I explain this? Let's say these values are covered through this value, and I have an X here. Now this X will say, okay, or I have 2 X's here. This X will say, this X is covered using this X. This X will say, should I be covered using this X or this X? That I can either skip all these values, go to this X, or I can actually call this X here. If you see, it doesn't really make a difference. Okay, or calling is beneficial. The reason is because when you're calling, you're not changing the array. Like you're changing the already used values, which doesn't really make a difference. Okay, but if you use this value, you'll actually lose all these values for the later part. And maybe these values are present after this only. So you need to always check if you have a value present already. If it is present, then use that. Otherwise, use the next present value. Okay, let me show the code as well now. Do keep in mind that while keeping this 1 and 5 or all the values which are not used, you need a multi-set, not a set, because the value can be multiple times. This is the mistake that I did. Okay, so I'll show my code. Okay. Okay, so this is the code. Let me explain this. Okay, so essentially what this is the part where I'm actually doing everything. Okay, so before this I'm just scanning my A array and my B array. Okay, then I made a multi-set. then my index actually tells me the index where I am at in B. So B index is for B. Okay. Now, and this is for A. This for loop is for A. Now I check if my current value in A is equals to the value I need for B. Okay. If they are same, okay, I'll say that index plus plus, that I can actually move forward in B also and in A also. So index plus plus for B and then continue. So I plus plus for A. Okay, but okay, now if the values are not same, then I need to first see if my last used value is equals to the value that I needed for B. If they are same, then I need to see, do I have a value present in my multi-set which is not used? So I see if it is present, then I just erase that value from my multi-set, make index plus plus and I minus minus, because I'm actually doing a I plus plus here. So I need to again go back so that I can come forward again. Okay. Otherwise, if this is not the case, then I just say that this value won't be used for now and I can just insert it into my multi-set. Video is lagging. Is that so? I don't think I can actually do anything about it. Hopefully this will get better in a minute. My Wi-Fi is okay, I think. Let me just check. Yeah, my Wi-Fi is doing fine. So I don't really know like why is this happening. Is it still lagging? We have to complete 2 more problems. Can you repeat that? Which part do you want me to repeat? Okay, if it is lagging or if you're not able to understand it, you can just go backwards in the stream as well. Okay, because I think it will be difficult for me to explain the complete logic again. Okay, yeah, I can explain the code. Okay, so what essentially was happening was, okay, yes, bhaiya. Okay, cool. Alright, I started from back and did almost similar. I actually did the same logic from the back first and I also got a wrong answer. Then I wrote the complete code for the starting. Code 1. Code 1. Okay, cool. Okay, so what I is actually for array A, index is for array B. So if my array A, I is equals to, A of I is equals to B of index, that means the value that I need for B and the value that I have in A are equal, then I can just increment my index, okay, and increment my I also and continue. Okay, but if they are not the same, then I need to see if my last used value in array A is equals to the value that I need. If it is equal, then I can check, do I have a value same value in my set present which is not used. So I check that. If it is present, I erase that value from my set because it is used now, and then I increment my index, and then I decrement my I. The reason for this I decrement is because I'm incrementing my I here. So, but I have not used this current I. I used a value from the, like, something that was not that was present in my set. So I have to check for this I again. So I just do I minus minus and then come on to this I again. Okay. If this is not the case, that means I'm not going to use this value for now and I can use this sometime in the future. So I need to put this into my set, multi-set, and move forward. When this loop ends, I might have some values still left in the set. Okay, so I just need to see what all values are left for B. Okay, and if they can be completed using my rest of values in set. So I do the same thing. This is the same thing here as well. And now if my array is complete, array B is complete, which means my index is equals to n, then my answer is yes, otherwise no. And that's it. Alright. Can you please explain second if in the for loop? This actually tells me that my I cannot be used for now because it is not equal to B of index. Then I need to see if my previous value that I use is equal to my current value I need in B. If it is equal, then I need to see if my previous value is present somewhere in my set also, which is not used. Why A of I minus 1 is equals to B of index? A of I minus 1 is equals to B of index. Where am I doing that? It is A of I is equals to B of index, and here it is A of n minus I is equals to B of index. The reason for A of n minus 1 is because we have completed the array A. That means the last value which I used is a of n minus 1. Okay, cool. Can you please explain this? I explained this, Rishabh, now. Why I'm doing a of n minus 1 here. Okay. And that's it for problem D as well. And I think we can move forward for problem E now. If in case you are still not able to understand problem D, just go back in the video when I'm explaining on the board like why this is happening, and then come to the code again, and then I'm pretty sure you'll be able to understand. Okay. Upwards and second. Okay. This is because I need to see if my last process value is equal to the value that I need in B. If you see, when I have an X, okay, now my I would be here. Okay, this is array, this is array B. My I would be here and my index would be here. My index will say that I need an X, but I don't have an X present here. So I need to see if my last value which I used in A is equals to X. Since these are same, that means I can use this X to call another X from the behind. So I first need to see if this X is present one step before this I. If it is present, I need to see if I have another value, spare value present with the same value. If it is present, I can just bring it here. And that is why I am doing A of I minus 1 is equals to B of index. Alright, I think that's enough for problem D now, and we can move forward to problem E. If you want my code, you can just go to my submissions, okay, in my Codeforces, and get them. Or you can take a screenshot from the video as well. If A of I minus 1 is not equal to B of index, then that means I cannot use any value for this particular index, and I need to put this. Okay, let me open the tab again. And I need to insert this in my set so that it can be used somewhere afterwards. Okay, and that is exactly what I'm doing in the code. If you see, if the conditions are not true, I just insert this into my multiset, which means that I'll use this value somewhere afterwards. Okay, cool. Okay, let me move to problem E now. I think we have used a lot of time. I says okay, aa gaya bhaiya. Okay, cool, perfect. Perfect, people. All right. Problem E is an interactive problem. How to implement that F1 in such short of time? I don't know. I just read the problem. I got the idea. I wasn't like 100% sure about the idea. So I just, since I didn't have any time, so I just coded the problem and then I got accepted. And then I thought about the logic, like why this is happening. Okay, cool. I wish I hadn't wasted a lot of time in problem D. Then I'm pretty sure like I would have been able to do problem E as well. I was not able to get the indentation of graph for that. Okay. All right. Okay, let's start with problem E now. Okay, instead of like reading the problem, or I won't read this paragraph. Okay, there are n words in a text editor. Okay, so we have n words. We have n words. Okay, length of word is in the range of 1 till 2000. So 1 less than equal to, this is length of word, less than equals to 2000. Okay, then the array L is hidden and only known to the grader. Okay, so we have n words. Length of any word is less than 2000 and greater than 1. Okay, the text editor displays words in lines, splitting each two words in a line with at least one space. Note that a line does not have to end with the space. So basically, let's say the line was okay, the line was my name is Naman. Okay, so as you can see, we need a space here, one space here, and one space here. And the length of the array is, this is 2, this is 4, this is 2, and this again is 5. So this is the array. Okay, so I need to find like what is the height I need for a given width. So let's say I fix my width as 6. Then I can insert my Then I need to put 4 spaces because I cannot insert name. Okay, then I put name. Then again I need 2 spaces. Then I put is. Again I need what? 4 spaces, and then I put Naman. So if you see, for a width of 6, I had a height of 4. Height of 4. And this is equals to 24. 6 into 4. 6 into 4 is 24. I need to find the best possible width. Okay, width and height, such that my W cross H width into height is minimum. Okay, and I need to return W into H. Okay, this is the problem. Okay, to do this, I can actually use n into what? How many queries? N plus 30 queries. N plus 30 queries. I need to do this in n plus 30 queries. Okay, now let's first try to understand. Okay, I'll keep this. I'll remove my board now. Okay, I'll remove my board. I'll remove the screen. Now let's take this line only. Okay, so we needed it max n plus 30 queries. Okay, Li is from 1 till 2000. Okay, so if this is the length, and what n is also less than 2000. Okay, cool. Now what if we first were able to find out the complete length that we need for the string? Let's say the string was my name is Naman only. So the string is my name is Naman. Okay, so for height equals to 1, we needed, this is 2. Okay, then 1 space, then 4, then 1 space, then 2, then 1 space, and then 5. So it is 2 plus 4, 6 plus 2, 8 plus 5, 13, and 3 spaces. So in total, you need 16 spaces. So if my height is equals to 1, my width is equals to 16. And for width 6, we already saw. Let's try for some other length. Let's say my width is 7. What if my width is 7? If my width is 7, I'll have my space name in the same line. Then I'll have is space. Okay. And then I'll have Naman. So again, this will have a height of 3. 7 into 3 is actually 21. This was 21. So again, my best answer is 16 only here. Okay. So using n plus 30 queries, we need to find out what is the best minimum possible value of W into H. Now, how to do this? Okay. Okay. So the idea behind this problem is that we know that whenever we are multiplying W into H, okay, either W has to be the minimum possible or H has to be minimum possible. If both of these are somewhere in the middle, then I'll get a bigger value. So I need to ensure that either my W is small or my H is small. What if I considered for H equals to 1? I know this is my least possible width, sorry, maximum possible width to contain the complete line. Now, if I try to find a W for H equals to 2, that means I had 2 lines. Okay, I'll have to take second half of the line, put it here, first half of the line, put it here, and try to make sure that they fit. It might be possible that this space was small and therefore a word was not able to fit here, so it had to be shifted to the next line, so it came here, and then this space was not used, so therefore one more line was used. If this happens, then this W into H will be greater than this W into H. Similarly, the same thing for height equals to 3. If I'm taking a height of 3, okay, then, okay, or let's do this. I know that when my height is 1, my W into H is actually equals to W only. So when I make my height equals to 2, my W into H is actually going to be 2 times W. Which means in order to get a smaller solution, my W has to be less than W by 2, which was here. This W by 2. Or let me call it total length by 2. Let's say this is total length. This W has to be less than total length by 2. Then only this answer will give me a better answer. Similarly, if my height is equals to 3, then my W into H will be equal to 3W, which means my W has to be less than total length by 3. Then only this W into H will be smaller than this W into H. Okay, and so on. Now we know that in total we have 2000 words. If we have 2000 words, that means the maximum height that we can go for will be 2000. Because after that we will actually be leaving lines empty, so there is no use of that. Okay. Now what if for every query, okay, just what if for every query you did a you asked, okay, or you did a binary search and asked them, sorry, in the starting you will need a binary search to find this width, okay, because you don't know any of these values. So you'll randomly give a value of width and then see if it is equals to 1. If my height is, anytime it comes to 1, then you'll say that this is the desired width. Can you please explain this again? Okay, I'll explain this part again. Okay, let's say for this complete sentence, somehow I was able to find out the total length of the sentence. Okay, and let's say I was able to find the total length of the sentence. Now I know that for H equals to 1, my W into H is actually going to be equal to W only, because my height is equals to 1. Now if I make my height equals to 2, that means I want to split my sentence into 2 lines. Then my product will be W into H, which is nothing but 2 times W. And for this, oh sorry, really sorry, I forgot about this. Okay, I'll explain the part again. Let's say this is the complete array. Okay, and let's say somehow we were able to find the total length of this string, which in this case is 13. I think we validated 13, 7, 8, 13, sorry, 16. It's 16. So basically 16 spaces are required. 16 spaces are required to fit the complete line into one sentence only, or into the complete editor. So for height equals to 1, my product will be W into H, which is W. If I try to split this complete sentence into 2 lines, then my space will be W into H, which is 2 times W, because height is 2. So H is 2 into W. For this 2 into W to be lesser than this W, I need to ensure that this W is nothing but total length. I need to ensure that 2 times W is less than total length, which means my W has to be less than total length by 2. Similarly, for height equals to 3, my W into H is going to be 3 times W. That means my W has to be less than total length by 3, and so on. And the maximum height I can actually go for is 2000 only, or L, because I have n number of words, which is like, okay, n number of words, and in the worst case I can have in every line 1 word only. Okay, and since I have like n number of words, my H will go till n only. So I need to do this 2000 times. First I'll query for the complete length only, which is already done. Then I'll query for total length by 2. Whatever my total length was, I'll query for total length by 2. What is the height I need for total length by 2? If it is equals to 2, then maybe this is an answer, or I already have an answer for that. Okay. Then I'll do for total length by 3, and so on. Okay. Now, to find this total length, how do we find this total length? We will actually start from 0 till, let's say, some large number, 10 to the power 7. Okay, because the total length of the string can be 2000 into 2000 plus 2000 spaces. So let's say 10 to the power 7 only. If you run a binary search for this part, you will get the total length, because all you need is the smallest value with which you get a height equals to 1. So for that, you can first do a binary search. Okay, so that will take how much? Log of 10 to the power 7 plus, then for every height you are asking for one width. Okay, so plus h only, or h is nothing but n, and the total queries you could ask for n plus 30. So n plus this is actually somewhere around like what, 20 only, not 20 actually, but 24 something. Okay, so this is less than n plus 30, so yes, this is the answer. Let me even show the code. Okay, okay, I can show you. Okay, tourist got a wrong answer. Okay, okay, let's see next. Mode, I think. Okay, so this is how you had to do. So if you see how we are actually doing is, I'm starting my making my L equals to 0, R equals to INF. Okay, then I just run a binary search to find when do I get a height of 1. Through this, I find out the smallest value with I have a height of 1. So this answer is nothing but my total length. Then I need to run it for a width, for all the possible width. Okay, so I do total length by 2 first. This R is total length here. Okay, and K is nothing, 2 first, then 3, and so on. So this W becomes total length by 2. In the next iteration, it becomes total length by 3. In the next iteration, it becomes total length by 4, and so on. And for every width, I find out my height. If it is not equal to 0, then I just check maybe this has a better answer. If they have, I update my answer, and then in the end, I print my answer. And that's it. And that is all you had to do for problem E. Again, the code is small, but the logic is good enough. Okay, you had to properly think about the problem, like how do we approach this? And I think we are good to go for problem, which one? F1. Okay, let's move on to problem F1 now. Let's move to problem F1. Okay, problem F1 is pretty easy. Okay, I'll explain like how. Can you share that code? You can just go to my Codeforces submissions and like get the code. Sharing the code on chat will be difficult. Okay. You can just go to my handle, or if you want, I can just paste the link to my code as well. Just a second. Give me a minute. Can you share that code? Okay, you need Omnix code or mine code? This is Omnix code. The code that I showed you was Omnix code. This. Yeah, you can take this code. Okay, cool. Okay, let's move on to problem F1 now. Okay. Already has an array A of length n which he really likes. Today you have changed this array to permutation B to be a permutation of A to make him sad. Because Olimri is only a duck, he can only perform the following operations to restore his array. Choose two integers ij such that I j are less than n, swap bi bj. The sadness of the array B is the minimum number of operations needed to transform B into A. Given the array A, find any B which is a permutation of A that has the maximum sadness over all permutations of the array A. Okay, so let's take the input. We have 1, 2, 3, 3, and the answer for this is 3, 3, 2, 1. How do we get this? We first swap these two values, so we get like 3 2 3 1, and then we swap these two values, so we get 3 3 2 1, and in two operations we were able to get this array again. So the sadness of this array is actually 2. Okay, cool. Now for simplicity, let's assume the array is sorted for now. Okay, let's say the array is 1 2 1 1 2 2 2 3 3 3 and 3. If you actually see, in order to have the maximum number of swaps, the array that you need to construct is just need to take all these 3s and shift them in the very starting. So the new array would become 4 times 3, then 2 times 1, and then 3 times 2. And that's it. This will actually give you the maximum number of swaps. The reason is because first you swap this 3 with this 1. So this 3 goes here. Sorry. First you swap this 3 with this 2. So this 3 goes here. But this 2, the value of this 2 is here. So essentially what you needed was, you wanted to shift this 3 at a place such that this 2 is farthest from its original position. The original position of this 2 was here. Okay, so when you shifted this 3 here, this 2 came here. And on the right side only we have all 3, so we cannot put this 2 here. So the farthest position from this position is this 2. Similarly, for the next 3 also, it will swap with this 2, and this 2 will come here, which is farthest from this 2, and so on. So the idea is, if you have, for a sorted array, if you have like A1 a couple of times, then you have A2 a couple of times, then you have A3 couple of times, okay, and let's say then you had A4 couple of times, and then you had A5 couple of times, your array, final array would become A5 all the number of times it was, then A1 all the occurrences, then A2 all the occurrences, then A3 all the occurrences, and then A4 all the occurrences. And this is the array which will give you the maximum number of swaps. Okay, now the array is not sorted in the problem. How do you do that? You just store the indexes of all the values. Okay, so let's say you had what, 1 2 1 3 2 1 3, or let's say this is 2 3 only. Okay, so all you have to do is, my 1 is, okay, let's make indexes 1 2 3 4 5 6. My 1 is present at index 1 and 3. My 2 is present at index where? 2 and 5. My 3 is present at index 4, 6 and 7. Count of 3 is maximum. So let's say I had 1 first, all the 1s first, then 2s first, and then all the 3s first. Now write the indexes. 1 was present at 1, this one was present at 3, this was present at 2 only, this was present at 5, this was present at 4, this was present at 6, this was present at 7. Now take all these 3 values, shift them to the very start, so this becomes 4, 6, 7, 1, 3, 2, 5. Which means at the 7th place, 5th place will come. At the 6th place, 2nd place will come. At the 4th index, 3rd index will come. At 5th index, 1st index will come. 2nd index, 7th will come. 3rd index, 6th will come. And at the 1st index, 4th index value will come. And that's it. That is all you had to do. Okay. Let me even show you the code. Code is a little complicated because first I made a map. In this map, I stored all the vectors. Okay. Then I found out which vector had the largest value. Then I took this out, formed a sequence of all these indexes. Then I put this in the very start, and then I swapped all the values. Okay. So let me even show my code. Okay. Okay, so this is the code. Little complex. I'll try to make it understandable. Okay, so what I'm actually doing is I'm just scanning the complete array, and then I'm making a map of vectors. Okay, so I'm storing for all the ones what all indexes were present, for all the 2s which all indexes had 2s, for all the 3s which all indexes had 3s, and so on. Then what I do is I make a vector, and in this vector I put the size of every vector which I had here, and the value at every vector. Sorted all these positions, reversed these positions because I need the maximum vector, size vector. Then my v of 0 is the vector which has the maximum length. So I stored that value. Okay, that this is the maximum value. Then I just, what I did was, for the complete vector, I made this position array. So this array which I'm actually talking about here, okay, this array, I made this 1, 3, 2, 5. Okay, or no, yeah, I made this array. I made 1, 3, 2, and 5. Then I reversed this complete array, tried to make this array again, and then shifted all these positions before, took these positions, put them here. And that's it. Can you tell me the logic of that farthest one? Okay, all you have to do is, okay, logic, okay. So let's say this is the complete array. You take all the array with the maximum occurrences and put them in the very start. Reason is because you know that this A5 is actually present here also. So when you swap this A5 with any of this A4, because this A4 is in the position of A5. So when you take this A5, swap it with any of the A4s, okay, this A4 will come here, A4 will come here. Now you need to ensure that this value when it came here is not already sorted, and it has to be at a good distance from its other value. And the farthest distance from this position is this index, because all the before values are something different. After this you had A5s only, so you cannot place them here, so only positions are this one. Okay, so that is why if you like cyclically shifted all the occurrences of A5 to the very start, this complete array will have the maximum number of swaps. Okay, and that's it. Again, I'll show my code. Little complex, maybe. Maybe it has an easier implementation. I don't think so. Let me just see other people's code. Maybe other people have done something easier. Maybe implemented it in a easier manner. The logic will be definitely the same only. Let me check. No, again the same thing. He's also doing the same thing. Okay, let's see for tourist. Uh, Again the same thing only, guys. Okay, so I don't think there's an easier implementation of this one. I'll paste the code for this problem as well if you want to see. F1 code. I think I can do this from the next time. Like I can paste all my the link to all my codes here. I think that will be useful. Okay. Anyways, that's it for the stream, people. We did problem A, B, C, D, E, and F1. I myself haven't attempted problem F2. Otherwise, I would have done that in the stream as well. But I think that's good enough. A, B, C till F1. Okay. I hope everyone got all the solutions. If not, you can just go back into the stream and watch it again. And do like the stream, guys. I only have 43 likes at the moment. Try to make it reach like 300 at least. Okay, and that's it. Bhaiya, only one request. Please don't stop uploading. I'm learning a lot from you. Thank you, Mohit. Okay, and also do subscribe to the channel also, guys. Helps